I spent hours looking for it this morning. That's awesome. So just let a few more people file and then we'll get started. All right, well, thanks for coming, everyone. Great crowd. So just a little bit about me. Personally, some of the things I like to do, besides development, I ride some bike, lots of bike, and play some hockey. So if you're interested in talking about any of those things after the presentation, I would love to chat with you. I'm just wondering, curious, just show of hands, how many people have had a chance yet to play around at all with Docker? Yeah, so maybe 10, 15%. And how about just generally reading about containers and kind of starting to understand what that's all about? So maybe less than half. So that helps me kind of gauge how we want to run the presentation. So I'm Paul Lundberg. I'm from Augusto, and I have my colleague here, Ray Pittman, who's been actually playing around with some containers. We've been doing a lot of playing around, and we've been doing just a little bit of real work in containers. So we're still, kind of learning and understanding how this is going to help us. Just for a little background on the kind of development that we do. So we're very Google focused on Google's platform, and so we take things from really a platform as a service approach, which really means that if you're familiar with App Engine on Google's platform, that's platform as a service, meaning that when we develop and deploy an application, we package it up and we hand it over to Google, and Google runs that workload for us. So we don't do a lot of setting up of virtual machines. You might be familiar with AWS, where I'm going to go set up my virtual machine, and then I'm going to get it all installed, and then I'm going to deploy my application to that environment, and then I'm going to have to take care and manage my virtual machines if I want to scale those or have more of those instances. Maybe I need to add a load balancer, need to kind of manage all the infrastructure. And with platform as a service, where I'm pretty convinced the world is going, I don't think there's any real doubt about it. The world of app developers really that you're just going to package up your application and you're going to deploy it to an environment, and that's just going to be run for you. And so another environment that has some lift right now is Heroku. People familiar with Heroku and running that? Same kind of thing. You package up your app and you run it in that kind of environment. So you don't have to worry about it. So that's our philosophy, and that's how we've developed just about all of our software and applications. So the reason that we've picked Google, I've kind of migrated in my work from Amazon to Google, is just because we're seeing that Google is really doing the most interesting things when it comes to highly scalable solutions. They've got real problems that they're solving for themselves that just go beyond what anybody else seems to need to do. And so if you have an interest like Augusto does in building highly scalable applications, then this is kind of the natural platform you gravitate to. A lot of these other platforms work just fine for doing kind of solutions for building applications that have hundreds of users or maybe limited amount of events. But if you've got, for example, an event processing system and you don't really know what the load's going to be and you need to be able to scale up and back down, then Google offers a platform that's really interesting. I'm just going to skip over those. So what I want to cover today is just help you. I'll give you a little context on Google and their platform because I know the most about that, and I think it relates pretty well to other platforms too that you read about. So I don't want it to be a Google-specific presentation, but I do want to just give you some background so you kind of understand the different types of computing, because you'll find those parallels really in any platform. And then we'll talk a little bit about containers and couple of the use cases that we have at Augusto for using containers. And those are just using containers for managing a development environment and using containers actually to handle specialized workloads. So we'll just go into that just a little bit. And then we'll just maybe touch on a few other topics as well. So here's what Google's Cloud Platform looks like, all the different components of it. So I mentioned in compute, the symbols there, really the two major ones are App Engine, which is I want to run as a service, and Compute Engine, which is I want to set up virtual machines and run those. And then there's lots of other services that Google has around that on their platform. So for example, for App Engine, the default database is going to be a NoSQL database called Data Store. So when you set up and configure an App Engine app, it already has a default data store. You don't have to really do any configuration. It's there and ready to go. Then they have an object store that allows you to store images or video or any of those kinds of objects. So that's cloud storage. And then other interesting services that may or may not be used are around big data and BigQuery. So if I've got my data coming into my main data store and I want to do a bunch of analysis on that and terabytes of data, I can configure BigQuery to be able to run some really pretty interesting queries against that data. So, so this platform has really evolved pretty quickly. Back in about 2008, they released App Engine, and what's really interesting about Google is they announced platform as a service before anybody was even thinking about platform as a service. And that was, Amazon was doing infrastructure as a service and virtual machines, and Google just came out and said, how about this? And so it was really interesting for developers, but practically the world wasn't really ready for it. And what they've done since is gone back and kind of filled in other types of compute, like infrastructure as a service with Compute Engine, kind of where the market is today, people that have servers and they want to move them into the cloud. I would still say there's a very small percentage of people doing platform as a service in any way. But Google's really working on all kinds of things. This is about the last 12 months or so, and just some of the things that they're working on. And a lot of these things are related to containers. And we'll talk about that a little further, but quite a few of these items are about containers. So what are containers? So we have come from a world, I've been through all of it, the whole history of this. Back when we just had physical machines and we were dealing with that, installing physical machines, racking them up in a data center, maybe our own data center, maybe a hosted data center, worrying about hardware and blinky lights and all of that. So makes me cringe just thinking about it. Then we moved on to virtual machines where we could run multiple machines or virtual machines on a single box. That was a nice step forward. Many of us probably today run virtual machines on our laptops and kind of understand what that's about. And then where we're heading and where Google's actually been for quite a long time is containers. So let's, so that's just another view of kind of how this has evolved more from, we've gone from just Linux and x86 to virtualization, and then public cloud, and then containers. So just very quickly, Google's actually had quite a bit to do with containers and how that's all evolved. So Google, in their environment, like all the services that you know about that run, whether it's Gmail or Maps or any of the services that Google runs are all really running in containers. They've had a container strategy for many years. It's really a sandbox environment that they have, and the numbers that they provide, this just like a month old or so, is that they're spinning up about 7,000 new containers a second and over 2 billion containers a week. So they kind of understand how this container stuff works, and they actually had a lot to do with where Docker is today. If you heard all about the buzz about Docker, a lot of that came from modifications to Linux and being able to organize and separate groupings of processes within Linux. And that really started all with C groups, which is a project involving Google back in 2006. And another key component, which is really the container manager, was LXC, and that's really what Docker has replaced with what they call Live Container, which is Docker's version of LXC. So, so Docker, and then, if you listen to the founders of Docker and how they talk about it, it's like there's been a lot of building blocks along the way, and they've just kind of come along and provided a way to manage containers that makes it accessible really to developers, to everyone, so that as an application developer, I don't necessarily have to be a Linux guru or a real systems person to be able to take advantage of containers. And I think that's why it's gotten so much lift very quickly. So back on that chart of technology that I said Google's been working on, these are all the things in red are things related to containers. So you just get a sense that this is going to be a pretty big thing. And Amazon's responding now too with their own container. Can't remember what they call their product, but it's a container engine that allows you to organize and manage containers. So just to kind of make sure we're all clear about what containers are and how they're different. So in the virtual machine world, we really have a host OS, and on top of that, there's a hypervisor that can run virtual machines. So we can have multiple virtual machines running on top of that hypervisor. So I could have, like on my laptop here, I've got running OS X, and then I can run VirtualBox as my hypervisor, and I could run an Ubuntu image and a Windows image, and I can boot into any of those, have them running at the same time. So that's virtual machines. It's very useful, and we've been doing that for a long time. So the way containers is different is that I'm actually running groupings of processes on within, in this case, Docker, where all those are sharing the same underlying OS. So I don't have multiple OSs running that are hosting my processes that I'm wanting to separate. So the advantages of that are that there's a lot less overhead, and that's why Google went to that when they've got billions of containers that they're running, is because the overhead of not having to have an actual virtual machine to run all these workloads that we want to separate out. It's just much faster and efficient. We can start these up very quickly, and we can shut them down very quickly. So that's the real difference. There are some issues with it that you have to be a little bit careful about. Containers are not necessarily secure as a virtual machine in the way they separate things out. So you need to be careful about what you're running together. You generally, today, I think, want to think about it as, if I have a solution and I'm wanting to separate out the components of my solution, it's just fine to use containers, because really what I'm trying to do is just separate them so that I don't have issues with configuration, and that I can replace one and not necessarily impact the other. But when you look at the security around that, it's not as secure as virtual machines, and that's a big thing that's being worked on now. Red Hat's, one of their key technical people, just constantly says containers don't contain. So he just wants to keep making that statement so people don't misuse containers. You shouldn't take one customer's stuff and put it in this container and another customer's stuff in that container if it could be sensitive. You need to be careful about how you're using containers. But I think that's all changing and evolving pretty quickly, and that a year from now that might not be the same kind of concern as it is today. Any questions so far? Just jump in if you have any questions you want to ask. All right, so let's just kind of look at an example then. So this actually the demo here we'll kind of take a look at is just slightly different than this, but this is kind of the picture here. We have a server, we have a host OS, we're running Docker. So Docker is our container manager. It's going to allow us to define a container and start it and stop it, and I can configure these so that they can communicate to one another. I could have two containers running under the engine that have no visibility of one another, or I could set it up so that this container can actually access that container, or effectively put them in the same network. And so I can have many different containers running. So as an example, the little demo we put together here has a couple different containers. So Elasticsearch, if you're familiar with that, it's a search index. And I can add things to the search index through a RESTful API. And so it's a really handy service if you're just trying to do full text indexing and build up a search index. And so the scenario here would be that I want to keep my Elasticsearch configuration, because let's say Ray's the guy that's taking care of that. He's going to build that container up and get it all ready and configured the way we want it. And then somebody else is going to work on, this is just really in the demo, it's a command line Ubuntu instance that's just capable of running curl. Just kept it really simple so that one container can access the other container. That could be your web app, or that could be some other kind of a service that's doing that. And so maybe I have somebody else that's going to be working on setting up and configuring that instance. And so I want to keep those separate. I want to maintain them separate. I want to upgrade them separately. But these things are needed. I need these things to work together for my solution, to carry out what my solution needs to do. So if you're in a development team, you maybe have a sense that have this experience where developer, there's all kinds of things to configure. I got the database, and I got the search index, and I've got this tool and that tool, and development environments are kind of fragile when you're running them on workstations. So, what if you could just have this whole collection of containers that were all kind of set to go, and I could just start them all up and they would just run. And if somebody made a change to one of the components, I could just update my configuration and just restart it, and I'd be set to go. So we can pass these containers around very easily, much like a virtual machine, except it's much smaller and simpler to work with. So in this example, just to kind of show you how simple it is, really, the configuration, this first line here is really what's needed just to say, I want to run a container that's running Elasticsearch, and we're setting up some of the default ports that it's going to use. And I'm basically going to name that container. And that actually creates a container image, pulls down Elasticsearch, and gets that set up, and it's pretty much ready to go. In fact, that command actually downloads Elasticsearch, creates my image, and runs it. So that image is actually running after I do that command.
Is that grabbing it from the Docker repository? Or?
Yeah. So that's going out and pulling it from Docker's repository, exactly. So different, I know there's other container management, and you'll hear a lot about container registries too, and that's where you're basically setting up, where your containers are, where they reside. So then for the second container, which is what we're calling my Ubuntu here, here I need to customize it. So rather than just pull the standard container, I also need to add something to that. So you can see there's a Docker file here that I create that really has two lines on it. One saying, I want to build this container as an Ubuntu 14.04. And then the next line says, and when you start this thing, I want to pull down curl, because I want to use that utility. So I could configure this to have lots of different components that are all going to get pulled down and executed when that container is created. So so now we have two different container images, and they're and ready to go. And I can now kind of run those together. So I can try switching over here. So if I just look at this command here, I can see, it's not very pretty, but basically this just tells me that that Elasticsearch container that we had in the picture, that's already up and running. So I just did a Docker PS, which just shows me the containers that are running under Docker. So, so on a Mac, to get this working, I had to install boot to Docker, which is really VirtualBox running on here. If I had a Linux machine, I could just run Docker. If I had a laptop that was running Linux, I could just run Docker directly on it. But with Mac OS, I need to run boot to Docker. A little bit confusing. Don't worry about that too much. But if you have a Mac and you're going to be trying to set this up, you'll have to set up boot to Docker. But now once Docker's running, now I can issue these commands. So here I'm just looking to see what containers I have running. So so now if I want to take that container that I have running, if I want to basically now launch that other Ubuntu container and have it install curl and tell these containers about one another, I'd issue a command like this that link. You'll see it's a link command. So I'm doing a Docker run. I'm going to run that container that exists, and I'm going to link in this Elasticsearch with my container called my Ubuntu. And then I want to fire up a bash shell with that new Ubuntu container so I can issue a command. So if I execute that, you can see it popped me right into shell. You saw how quick that started. It was just, and now here, if we go back to my slides, I don't know what that. Oh, I guess I got them off the network. Oh, hang on one sec here. Okay, so now I'm in the Ubuntu container, and now I just wanted to basically do a curl statement to send something over to that other container. So just to kind of prove that they're networked together and that they're available and that they're two containers are kind of cooperating. So now if I just go over here and find my, one sec here, one of these. Here we go. So if I look for like a tweet, I just basically sent over something to add to the index. So if I do a index 3, which is the one I just added, it'll just show me that it'll respond with what's in that index. So just a very simple example. It's when you're setting these things up, it's really good to just pick something really straightforward so you can just kind of conceptually really understand what's going on. So any questions about that? You can imagine that you could configure containers really however you want. I mean, we really are heading down the path of using it for development environments so that someone's having trouble with their development environment, something's messed up, they can't figure out why, just start over. Just grab the latest configurations that maybe collectively the team has built up and just run it and start over. You don't need to. You're not on your laptop directly trying to figure out what went wrong, and there's just so much stuff that gets piled in, and in this way you're keeping it very isolated. So,
so with that Docker file, you weren't actually running Ubuntu as much as it was pulling down the Ubuntu like binaries and libraries, and then installing curl into that environment. So like, there's not another Ubuntu OS running there, right?
Right. So what it's doing is it's using the host Linux operating system, the kernel of that to run that container. So I'm not actually firing up a whole nother virtual machine. I'm basically just running that as a container on top of my kind of host OS, on top of Docker.
So you had two containers talking to each other. Is that typical that you're doing that through the networking stack, or is there an API that you could have run where containers can talk to each other a different way? I mean, that was a RESTful API, example that you had.
Right.
Is there another example of how you can get containers to talk to each other? going through the whole networking
Through-
stack?
Through the net. Well, what you're really doing, and I may let Ray speak to this, but you're creating a little private network, and you're opening up the containers to be able to communicate through.
So that's your only method of container-to-container communication?
Yeah, as far as what I've seen. Do you have
You
any?
can share volumes too, so you can have them so that you can have two containers sharing the same directory. So, yeah, you can configure containers to share volumes as well. So that if you have files that you need to share among containers, that's another option. But really, you want to keep these things isolated. So the point of having these containers separated is so that they stay isolated from each other anyway.
What's the mechanism for kind of controlling your network, like spinning up DNS for each container, or firewalling for each container, or controlling IPs for each container, that sort of thing? Is that part of the container infrastructure?
Do you want to speak to that?
I can try.
I'm a networking guy.
So I guess you don't really, you don't have to deal with the network. So if you look at, if you can go back to the example where you fired up the Elasticsearch container originally, where you configured it, and go up a couple maybe. Yeah, there, that one. So here it says Docker run, and it's got the ports. So you configure, in that example, he's configuring see, it says 9200:9200. So the first 9200 exposes port 9200 to the outside world, and the second one tells it to map it to whatever service is running on the container. So you could do, like, for example, you could do, say you're running like a Tomcat on 8080, and you wanted to expose it from 80, you do 80:8080. So I don't think it's really Docker's place to deal with firewalls and things like that. You'd want to do that outside that. So in the case of, and if we get to it, there's an example where we're using ContainerEngine on Google's platform. And the firewalling and network configuration for outside that is configurable outside that. It doesn't have anything to do with configuring it when you're bringing these containers up.
So basically, each container, they all share the same network IP of the host that the containers are all on.
Yeah.
Any other questions just on basic starting up containers and how they work? Yeah.
What's a good way to manage environment variables and such between development and production and stuff? How do you keep that organized so we can have different steps for each environment?
So you mean if you were trying to manage?
Maybe your Docker containers for development is awesome, and then when you use the same container kind of configuration in production, they're going to be using like your real databases and your real setup where like development you might be like a smaller or no SQL kind of thing, and in real life you can use Mongo, sharding cluster and stuff.
Oh yeah.
So you got all these environment variables that are different between your local dev environment for your home or your laptop versus in your huge, Google environment where you got 100 containers all talking together.
Yep. Yeah, actually, I think the example we're going to go into that's specific to managed VMs on Google's platform will kind of show that a bit. So really what Google allows you to do is run your environment locally. And with managed VMs, they're kind of layering so that you're not really having to even deal so much directly with Docker, at least in your use of it. But I think when you get to that, let's see if we've answered your question about that. So let's just skip ahead here. So let's go into this managed VM example. So I told you that at Augusto, development is a really good use for us for containers. There's actually some uses for production applications as well. And I mentioned that we like to do everything in App Engine. The limitations of App Engine, however, are that you're running in a sandboxed container, where it really is a container, but a sandbox computing instance that Google provides. So because of that, it comes with some specific versions of libraries, and I can only customize it to some degree. It's the advantage of it is that it'll scale up and down to handle the load as I want it to, as I configure it to do that, and I can just deploy my app. So, but we've run into some specific cases, and these are the 3 so far, where we said, you know, what we need to do as part of this solution, we really can't do with an App Engine container. We need to go beyond that. And the first one is doing image processing. So we wanted to use ImageMagick to be able to process images, and the App Engine Sandbox doesn't really allow us to do that. Doesn't have that library. So what we had done, what we would have done in the past, is set up a compute engine instance, which is a virtual VM that's running in Google, much like AWS, where you'd set up a virtual machine, and we would set up now we're back into the infrastructure business of setting up a whole Ubuntu image and configuring it with ImageMagick and all of that, and somehow making it available so we can invoke that from our App Engine instances that are running that need to have image processing done. So that was kind of the old way to do it. Is you'd have your App Engine running, and you'd have a compute engine running, and they would work together, but they're 2 completely different projects.
Can't you add ImageMagick libraries to Google App Engine?
You cannot modify the container, the sandbox container that App Engine offers can't be modified in that way.
But can't you upload your own libraries and include them? No.
Yeah, you really can't, but with managed VMs, which we're getting into, what's starting to happen is that they're starting to blend the capabilities of this sandboxed App Engine environment and this need for customization. So just like in this case, what I really want is I want to be able to run App Engine. I want Google to scale it for me, scale computing instances up and down, but I got this one thing I want to do that really isn't fitting with Google's standard container, their sandbox container. So what a managed VM allows me to do is exactly kind of what you're going to, which is to create a modified version of a container that Google will scale for me. So just a couple more examples. So Elasticsearch, the example that we just took a look at, we actually had a requirement that Elasticsearch is really good for in a solution. So we had our whole solution all running in App Engine, but there was this one thing, this Elasticsearch that we wanted to do separately. So again, we set up a compute engine instance and had to manage and worry about how that's going to scale and all of that separately from our kind of core application. And the third one, which you're actually involved in right now in a project, was that we have some scientific computing that we need to integrate into our application. And it turns out it's very memory intensive. It's actually our customer developed the algorithms that we're inserting into our event processing stream, and it takes a huge amount of memory, the tooling that they're using for this scientific computing. And again, Google App Engine computing increments or sandbox containers are limited in what they can do in terms of memory. They have a maximum of 1 gigabyte of memory, as an example. So anyway, so what managed VMs allows me to do, so this is kind of the old way. I've got in a single Google Cloud Platform project, I've got some different modules. So that's nice because I've got some separation there. I can configure and deploy those separately as modules, and they can all be part of one deployment, which is good. And in this case, you see they're both App Engine. One is our event processing, one is our predictive analytics, and they're sharing a common data store. So that's what the picture looked like for, which would work great, except that I'm having some memory issues with that App Engine container because I'm limited to how much memory I can have. So changing the picture slightly now, the second box is now called a managed VM. And what a managed VM allows me to do is configure, it actually uses a Docker container, and it is configured out of the box to be able to access all the Google platform things that I normally would be able to access with an App Engine container. or a sandbox container. So I can access data store out of the box when I fire that up. I don't have to worry about that. But now I can actually choose some characteristics about the compute that I want in terms of processor and memory. And so what I'm really getting now are all the benefits of App Engine in terms of just deploying my app, but I can customize that VM a little bit. So let's see, I'm trying to look at time. I'll just kind of run through this pretty quickly, but this is just a standard setup. What I'm basically doing is I'm installing Docker. Well, actually, let's look at a few of these files. So besides writing all my code when I want to provide some directives to Google to say how I want to run my workload, in App Engine, which is over on the left, what I'm kind of building up here are, again, two modules. One is going to run standard App Engine, and the other is going to run managed VM. And Google's going to scale them both for me. And so the way you provide some directives to App Engine is through a file called the app YAML, which goes into your code base, and it's the directives telling it things like what runtime do you want to use. So I want to use the Python 2.7 runtime in this in this App Engine container, and what increment size do you want to scale with? There's F1 through F4 on front-end instances, so I can kind of specify, basically how big a computing increment I want to use, because I'm going to get charged by the computing increment when it's running. That's how I get charged for usage. And then I can set how many maximum instances do I want to run, and just some other settings basically. And it basically says when this thing fires up, I want it to run this module. It should be connected with this module that I call sandbox module. So if we look over here, I've got a little more going on, but it's basically exactly the same thing. I create an app YAML, and I just set some different directives to tell it that instead of using a sandbox App Engine container, I want to use a managed VM container, which is going to really be a Docker container that Google is going to run for me. So same kind of settings. I tell it it's Python. Now I say VM equal true to tell it that I want to manage VM, and I can set some directives on CPU and memory. Now I'm open to setting the memory to much larger, and I can set the compute and the memory, disk size, things like that. I have a lot more control, so I can go up to 100 gigabytes of memory if I wanted to in this case. And just like App Engine containers, it will do the scaling for me, so I can tell it how many instances I want to scale, and there's a bunch of other directives. Whoa, sorry, there's a bunch of other directives as well. So in this case, I've got a simple little application that just does kind of a hello world. In the sandbox module, the other thing is because it's a sandbox container, it doesn't have access to the file system on the box. So like when I'm doing that file, if I want to do that ImageMagick's workload, I want to be able to write files to the local file system. Well, in a sandbox environment, you typically don't do that. You've got your application's running, it's writing to the data store, and you really don't have any need for local disk. But in this case, in that file Magic's or ImageMagick example, I actually do want to write to the disk. So this little example says, it's just kind of a hello world, and in my other managed VM, I'm actually kind of doing my hello world. I'm also just showing output from the file system to prove that I can do that. So let's just go back and kind of deploy this. I'll just show you the command that I used to. So here, this command, I'm doing Gcloud, which is Google's command line for doing this stuff. I'm saying I want to preview this app and run it locally, and I want to run these two these two modules which I've defined. One is a sandbox module, and the other is a managed VM module. So this basically, basically uses those YAML files to kind of direct how this thing is going to be deployed in my local App Engine environment. And to deploy this to Google's Cloud, it's exactly the same command. There's just a one-word directive difference here in what I say to have it actually deploy to Google's Cloud. So if I execute that, it should fire all that up in my local environment. And if I go over and hit those ports that I've defined, localhost 8080, I'll see my message from my sandboxed environment that's running. And if I go look at 8081, which is my managed VM, I'll see the output from that, and it'll list out the the directory. So I know that that's not a sandboxed module. So what Google's doing is allowing us to start to set up, and really when I'm doing these commands, I'm not really doing what looks like Docker. There is a little bit of that setup that I did in the YAML file, but it's allowing me basically to fire up a managed VM and containers and start to mix and match those. So now, instead of having two completely different Google Cloud Platform projects and deploying those things separately, and where I had that specialized workload having to manage the scaling myself, now Google's going to do all that for me. So that's a lot of what's going on right now on the platform, is that they're starting to give us the ability to do kind of this blend of infrastructure as a service and platform as a service. What we've traditionally thought of. It used to be pretty clear cut about how you would do it, and now there's just a lot more options. Just going to skip down. So I'll just finish up with let's see, how do I run this thing without having to, sorry, I got to go to find my slide. Here we go. So another, if you can imagine with all these containers running, like just think about Google and how they're running, billions of containers. I've got all these individual containers. A big question you get into as you're starting to put together solutions, and you've got lots of solutions, is how do I manage all these containers? How do I keep track of them? How do I launch a configuration of containers? And so that's where you're starting to see really, Google's been doing this internally for a long time. They've had an initial project called Borg that's now, and then Omega. And what they've started to do is open source some of the way they do container management in a project called CooperNettie, which is a open source project. And they're taking what's really much like Kubernetes, and they're starting to make it available on Google Cloud Platform as a product that they call ContainerEngine. So you can go use Kubernetes to, if you're outside of Google's platform, you can use their open source project that they've started to kind of do your container management, or if you're on the platform, you can use ContainerEngine to basically organize my configuration of containers and be able to start them up and stop them as kind of a configuration. So Ray, do you want to, I know you built a little demo that I didn't actually have a chance to include. Can you just maybe just talk about that briefly and what you did there?
Which one?
The ContainerEngine demo? Just to speak to what that would be useful for.
I guess. So do you have any slides or anything, or do you not even?
No,
No.
I just talk about how, I mean, basically it's just a way so that we can start up all those containers at one time, right? So
Yeah. So
scripts to do it. You can kind of organize your containers into an
yeah,
engine.
yeah. So with ContainerEngine, in I don't know, there was 4 or 5 commands I ran his demo that he showed with where he brought up the Elasticsearch and that other container. We do the same thing in Google's using ContainerEngine in Cloud Platform. I think there were actually less commands. I think it was like 4 commands. So in 4 commands, you can have containers running, accessible from the internet. It's the same thing. It just pulls them down and from the repo, from the Docker repo, and they just work. So I don't know. I don't really have much else to say about it.
Yeah, it's still in alpha, so it's pretty new. You'll find that Amazon has a similar kind of thing that's going on right now, but they're basically, if you get beyond just using them for a few simple things like development environments or my one solution, and you've just got containers all over the place, you need to start to kind of have a way to organize those and be able to start them up, shut them down, keep track of all these containers that you have out there. So that's really about what these container management.
Yeah, I will say I'm really excited that when I can, because normally I have to take care of the VMs that are running all these apps, and I'm going to be really excited when I can just do this instead and not have to worry about the VMs. So, which is, just worry about the app running in the container. Let somebody else take care of the operating system and patching and making sure it stays running. And I think that's huge.
Right. So maybe just one more thing I'll comment on. So there's kind of something to think about in terms of containers. Like a lot of people say, well, containers are going to be great because they allow me to take my workload and move it from Google's platform over to Amazon. And that can be true. I think there's something to think about when you're architecting the solution. A lot of what the benefit is of Google's platform, or maybe perhaps another platform that you're using, is that they have services and APIs that you're using that are really, really highly leveraged in terms of reducing the complexity of what you need to worry about. So as an example, when we build applications, we're using data store, and it's a NoSQL database. But it's not just a NoSQL database. When I make a write to that database, before it even tells me it's written it, it's already in 3 physical locations, at least 3 physical locations, and distributed and backed up. It's the kind of thing that if you went to roll your own would be really complex. Same thing with services like BigQuery. If you're leveraging those in your solution, BigQuery is specific to Google. If I want to leverage that, I can't just pick up my solution and move it over. So I have to think about how I'm architecting my solution and whether this thing needs to be portable in a way where I could just pick it up and I could run it on Google and I could run it in, let's say, another environment like Amazon. It can be done, but the downside of it is then you may not be able to hook yourself into some of those really valuable APIs that are on that platform that make your development faster and make your solution a lot more resilient because of all the benefits of these services that the platform offer. So our approach has been, just because of our requirements, we're building to leverage the platform, which means that even when we're doing managed VMs, or even if we did all of it in managed VMs and it was all containerized, we still can't just pick that up and move it over to another platform because we're very tied into what Google's offering in terms of their APIs. If I did build it so that I could pick it up and move it, I would have to give up the use of a lot of really useful services that are saving me time and providing a lot of benefits. So a lot of what I hear around containers is the infrastructure people kind of thinking about how awesome this is going to be if you're an infrastructure person, because now I don't have to deal with virtual machines. I've got this new thing, and it's simpler and very powerful. But from an application developer's perspective, I think containers are a little bit different, and that was more what I was covering here. And so we're going to continue to leverage this platform that we're on. If we ever have a requirement, and it could happen where we're building a product for a company and they say, I need this to run here and I need it to be able to run there, then we'd have to take a completely different approach. And in either case, we're probably going to be leveraging containers in some way. So I think you'll see a lot more about this over the next, I would say, next 3 years. It's kind of at the height of buzz right now. I mean, everybody's talking about it. I'm sure there'll be a little drop, but I think containers are, I think, here to stay, and I think going to be really important. And I think it'll be one of those things we look back on in history and say, just like virtual machines, containers are one of those things that happened in the whole evolution here of things that was really important. And I think I'm pretty convinced we'll see that. So, any questions?
Yeah, do you guys use any tools like, or have any need for any tools like SaltStack or Chef? Or do you use any orchestration stuff with containers, or does Google provide a good solution?
For us, and the way we're approaching it is leveraging platforms as a service as much as we can. We don't get into Chef and Puppet and all that kind of VM configuration stuff. So we've never touched it. And I think if we do have those needs for more specialized workloads in that, our environment for that's going to be more like ContainerEngine, where we'll be configuring Docker, we'll be making Docker configurations, and we'll be configuring those in ContainerEngine, and that'll be our orchestration. So, but again, that's coming from a very application developer platform as a service orientation, and that's not where everybody's at. So, other questions before we wrap up? All right. Well, thanks so much. Thanks for coming. I appreciate it.